You're most welcome, folks, to this our YouTube channel. Now today I'm going to experiment for you the design system of Nikola Tesla battery swapping system. It's practically practiced here and designed through on Proteus. So I'm going to explain to you everything before simulating. I'm going to clearly simulate everything. You can see the simulation here. That's where we simulate it from, up there. But let me first explain here how everything works. Now this is a battery source, and here is the capacitor. Now this capacitor is isolated from the battery through the switch. Now after charging the capacitor, we can isolate it so that the whole system is isolated. Now the voltmeter here measures the volts across the capacitor, and the wattmeter here measures the current or the power input into the system. The system that I'm speaking about now, we are using a inductive load, which is a motor. Now the motor is just like a passive load that helps us to connect or to pass power, the energy from the input capacitor to these two capacitors. Now in parallel, these two capacitors are charged up through the load, and then afterwards they are fully charged. We switch, we flop them up so that the two capacitors are in series, and now they start charging back the first capacitor, the input. Now in this system we use this switch here that will switch this SSR relay. Now this is not SSR, but it's a relay. It has a contactor. Now this is its armature. I'm going to show you how it works also. Then we have a meter here that measures the current input. The voltmeter measures the current. These two, the current ammeter measures the current through the motor, and the voltmeter the voltage through the motor, and the wattmeter is measuring the power, because it's now the product of the current and the voltage that is passing through the motor. And here we are having the voltmeter that measures the voltage through this first capacitor, and the wattmeter measures the watts through this first capacitor. Likewise, to this capacitor, the voltmeter measures its voltage here, and also the wattmeter measures its wattage through this capacitor. Now let us start the simulation, and we see. First of all, let me run the simulation. You see, it has started in this way. Now the reason being, I've not connected, it's saying 16 volts, the input capacitor, the main capacitor, because I've not switched the battery onto the system. Now let us try switching. Now when I switch this switch, it means this capacitor is coming to full charge to 100 voltage, the voltage of the capacitor of the battery. Then see what's happening. The voltage through these two capacitors is rapidly increasing. Now that rapid increase, it shows you that it's in parallel. I should see what's happening at the switch. It's open. So when the switch is open, when this switch is open, it shows you that these are in parallel, so they are fully charged so that they can meet this voltage, the voltage of the input capacitor. Now you can check on the watts input onto the motor, the watts through the capacitors, this one and the other one, and also you can check on the watts input. Let us check. Now here it's a positive. These are voltage. The voltage here is positive. Check when we connect in series, means that the polarity will change. Let me first disconnect. Isolate this voltage. Now I've isolated the voltage through the capacitor. Now see what is happening. Of course it's still charging, but the voltage through this capacitor it reduces a bit because of the effect. Now let me try to flip-flop so that whatever has been the other side through these two capacitors that have been charged, see what is happening. I think what is happening to this voltage is positive, and the voltage goes on reducing because this voltage now it's increasing 109. We are charging this first capacitor. Now see what is happening here on the voltage. This one is producing negative, meaning, and the current negative. It means that the load through here is charging back into the system. So through here we are going to do much more experiments, and this is manual. I'm going to introduce a pulse generation through an ammeter, through SSR relays, and also the faster switching systems, so that we can see how the loads are working together with the input voltage and the wattage. Whatever voltage is going to be happening and the wattage that is within the system is going to be recorded in actual time. Then we finally put it into practice after seeing the simulation. Thank you very much.